All right, so picture this. You're working on this huge software project. It's like building a giant, intricate machine. But every time you try to tweak one tiny part, bam, something else breaks. It's a maintenance nightmare. Sound familiar?
Oh, yeah.
Today's deep dive tackles that exact frustration. High cohesion and low coupling. These aren't just fancy buzzwords. They're the secret sauce to building software that's not only robust, but also adaptable and honestly a joy to work with. Imagine making changes without setting off a chain reaction of bugs or understanding a chunk of code just by glancing at it. That's the power of these principles.
You can think of it as building software that's future-proof. You're not just coding for today. You're setting yourself up for smooth sailing down the line.
I love that. Okay, so let's unpack this, starting with cohesion. Help us wrap our heads around it.
Well, high cohesion means grouping things that belong together, kind of like Marie Kondoing your code base. Think of a well-organized toolbox. Your wrenches are all together, your screwdrivers have their own spot. It just makes sense.
Right, because digging through a jumbled mess of tools wastes time and honestly makes you want to pull your hair out.
Exactly. In code, high cohesion means each module or class has a single well-defined purpose. It does one thing and does it well. This makes your code so much easier to understand, maintain, and debug, because you know exactly where to look for things.
So low cohesion is like that dreaded junk drawer where everything is just thrown in haphazardly.
Precisely. You might have a module that's trying to handle user authentication database connections and sending emails all at once. It becomes a tangled mess.
And that's a breeding ground for bugs, right?
Right.
Plus, if you need to make a change, who knows what else you might break.
You're spot on. It becomes a risky game of whack-a-mole. Now, let's think about how to spot low cohesion in your own code. Imagine you have a class that's growing longer and longer, packed with methods that seem unrelated. That's a red flag. Or maybe you have a function that's doing 5 different things at once. Another sign that things aren't properly grouped.
So basically, if a module feels like it's trying to do too much, wearing too many hats, that's a sign it might have low cohesion.
Yes, and remember, high cohesion isn't just about organization for organization's sake. It's about reducing the blast radius of changes. The more cohesive your modules, the less likely a change in one place will ripple out and break things elsewhere.
That makes a lot of sense. So high cohesion helps us make changes with confidence, knowing we're not going to accidentally trigger a domino effect of bugs.
It's about creating code that's more robust, adaptable, and frankly less stressful to work with.
Okay, so we've tackled cohesion. Now let's dive into coupling. What's the simplest way to explain this concept?
Low coupling is all about reducing dependencies between different parts of your code. Imagine your code base as a network of interconnected components. With low coupling, these components are like well-designed APIs. They communicate with each other clearly and efficiently, but they don't rely on each other's internal workings.
So it's kind of like modular furniture for your code. You can rearrange things easily as your needs evolve.
That's a fantastic analogy. You can swap out a couch without having to rewire the entire electrical system. In software, low coupling means you can modify one component without setting off a chain reaction of changes in other parts of the code.
Okay, I'm starting to see how this fits together. High cohesion keeps related things neatly bundled, while low coupling minimizes the dependencies between those bundles.
Exactly. You're building a system where each part can do its job effectively, without being overly reliant on the inner workings of other parts. Now think about a time when you changed a seemingly small piece of code, and it cascaded into a nightmare of fixing broken dependencies all over the place. That's high coupling in action.
Oof, yeah, been there, done that. Not fun.
Yeah.
So what are some telltale signs that our code is too tightly coupled? Things to watch out for.
One of the biggest red flags is if small changes require modifications in multiple seemingly unrelated parts of the code base. It's a sign that your components are too intertwined. Another clue is if you find it difficult to test individual components in isolation. If you need to set up a complex web of dependencies just to run a simple unit test, that's a sign of tight coupling.
So it sounds like low coupling is all about creating a system that's more flexible and resilient to change. You're not constantly walking on eggshells, afraid to break something.
Precisely. And that's not just about peace of mind. It also allows for faster development cycles, easier testing, and smoother collaboration.
Okay, so we've got the basic concepts down. High cohesion, low, coupling two sides of the same coin when it comes to building well-designed software. But why should you, the listener, care about all this?
Because believe me, the real-world impact of these principles is huge. It's the difference between coding with a smile on your face and wanting to chuck your laptop out the window.
I think we've all been there at some point. All right, so in the next part of this deep dive, let's get practical. How can our listeners actually achieve high cohesion and low coupling in their own projects? What are the tools and techniques they can use?
We're going to explore that along with some common pitfalls to watch out for.
Sounds good. Stay tuned for part 2. Where we'll get into the nitty-gritty of putting these principles into practice. Welcome back. So far, we've explored why high cohesion and low coupling are crucial for building software that's easier to understand, maintain, and scale. Now let's get down to brass tacks. How do you actually put these principles into practice?
Well, it's easier than you might think. One of the most powerful tools in your arsenal is the single responsibility principle.
Right, we touched on that earlier. It's all about giving each module or class one job and one job only. But how do you determine what that one job is? It can be tricky, right?
Yeah. It can be, especially in complex systems. But think of it this way. If you find yourself describing a module with the word "and" a lot, like this module handles user authentication and database updates and email notifications, that's a sign it might be trying to do too much.
Ah, I see. So if you can replace that "and" with "by," you're on the right track. This module handles user authentication by verifying credentials. This other module handles database updates by interacting with the database.
Exactly. That's a great way to think about it. Break down those multifaceted responsibilities into smaller, more focused modules. You'll end up with cleaner, more understandable code.
Okay, so the single responsibility principle helps us achieve high cohesion. What about low coupling? What tools can we use there?
Dependency injection is your best friend when it comes to minimizing coupling. Instead of components creating their own dependencies, you provide those dependencies from the outside.
I've heard a lot about dependency injection, but to be honest, it's always seemed a bit intimidating. Can you demystify it a bit?
Absolutely. Let's say you have a class that needs to send emails. Instead of having that class directly create an email sending object, you pass in an email sender object as a parameter, often through the constructor.
So the class doesn't need to know the specifics of how emails are actually sent. It just says, give me something that can send emails and I'll use it.
Exactly. This way you can swap out different email sending implementations without modifying the class itself. You could have one implementation that uses a cloud-based email service, another that sends emails through your company's SMTP server, and you can even create a mock email sender for testing purposes.
Wow, that's powerful. It makes your code so much more adaptable and testable.
Another powerful technique for achieving low coupling is to design your code with interfaces.
Right, interfaces. I remember learning about those in my object-oriented programming class. But how do they relate to coupling?
Think of an interface as a contract. It defines a set of methods that a class must implement. So instead of depending on a specific concrete class, your components can depend on an interface.
So it's like saying, I don't care who you are, as long as you can fulfill this contract.
Exactly. This creates a clean separation between components. Let's go back to that email sending example. You could have an interface called email sender that defines a method like send email. Any class that implements this interface must provide a concrete implementation of that method.
I'm seeing how this creates flexibility. You can swap out different email sending classes as long as they adhere to that interface.
Precisely. And it also makes your code more readable. When you see that a component depends on an interface, you immediately understand what it needs without getting bogged down in implementation details.
Interfaces and dependency injection. They sound like a powerful duo for achieving low coupling.
They are. And let's not forget about establishing clear API boundaries. This is all about defining how different parts of your system communicate with each other.
So it's like setting up rules of engagement for your code.
Exactly. You specify what data can be passed back and forth, what methods can be called, and what responses are expected. This helps to prevent unintended dependencies from creeping in. It's like having a well-defined protocol for communication.
Okay, all of this is starting to click, but I'm curious. Are there any common pitfalls people fall into when trying to apply these principles?
Of course. One of the biggest mistakes is over-engineering. Some developers get so focused on achieving perfect cohesion and coupling that they create designs that are overly complex and abstract.
So it's like trying to build a house that's so structurally sound that it ends up being unlivable.
Exactly. These principles are tools, not rules. Use them judiciously. Keep your code clean and practical. Don't introduce unnecessary complexity for the sake of purity.
Right. It's all about finding the right balance. Any other pitfalls to watch out for?
Another common trap is premature optimization. Sometimes developers try to optimize for cohesion and coupling before they have a clear understanding of the problem they're solving or how the code will evolve.
So it's like trying to perfectly organize your kitchen before you even know what kind of meals you'll be cooking.
That's a perfect analogy. Focus on getting your code working correctly first, and then refactor for cohesion and coupling later as the design becomes clearer.
Solid advice. Any other words of caution?
Sometimes, in an attempt to achieve low coupling, developers can inadvertently sacrifice cohesion. They might break up a well-structured module just to reduce dependencies, scattering related functionality across multiple modules.
So it's like taking everything out of your kitchen cabinets and spreading it all over the house, just to say that no single room has too much stuff in it.
Exactly. You end up with a fragmented mess that's harder to understand and maintain. Always strive for that sweet spot where cohesion and coupling work in harmony.
Great point. Don't let the pendulum swing too far in either direction. Any other tricky pitfalls we should be aware of?
One of the most insidious pitfalls is hidden coupling. This occurs when components have unintended dependencies, often through shared state or global variables. It's like having a secret tunnel between two parts of your code that you didn't even know existed.
And those secret tunnels can lead to all sorts of unexpected consequences, right?
Absolutely. Hidden coupling can be very difficult to spot and debug, so be mindful of how you're sharing data between components. Avoid global variables whenever possible, and favor explicit dependency management.
Excellent advice. So we've talked about tools like the single responsibility principle, dependency injection interfaces, and API boundaries, and we've highlighted some common pitfalls to avoid. What's the key takeaway for our listeners?
High cohesion and low coupling aren't just theoretical concepts. They're practical tools that can make your life as a developer easier and more productive. By applying these principles thoughtfully, you can create code that's robust, adaptable, and a pleasure to work with.
Well said. But I think we've only scratched the surface.
Awesome.
How about we dive into some real-world examples in the next part of our deep dive?
I'm ready when you are. Let's bring these principles to life.
All right. Welcome back to the final part of our deep dive into high cohesion and low coupling. We've explored the concepts we've talked about, practical techniques, and common pitfalls. Now let's see these principles in action with some real-world examples.
Okay, great.
Ready?
Let's start with a classic example. A simple e-commerce application. Imagine you have a module responsible for processing orders. In a poorly designed system, this module might handle everything, from validating customer data to updating inventory to sending confirmation emails. Talk about low cohesion.
Yeah, that sounds like one overloaded module. It's doing the work of 3 modules, maybe even more.
Right. But by applying the single responsibility principle, we can break down this monolithic module into smaller, more focused units. You could have one module for customer validation, another for inventory management, and yet another for handling email notifications.
I see how that immediately makes the code more organized and manageable. Each module has a clear purpose, and you know exactly where to look if you need to make a change.
Exactly. Now let's think about how low coupling would come into play here. Imagine that you want to change the way you send emails. Maybe you're switching from one email provider to another. In a tightly coupled system, this change could ripple through your entire code base. But with dependency injection and interfaces, you can isolate the impact.
You'd have an interface like email sender that defines the methods for sending emails. And each module that needs to send emails would depend on that interface, not on the specific email provider implementation.
Precisely. You could then have different concrete classes implementing that interface. One for your old email provider, one for your new provider, and maybe even a mock implementation for testing. You could swap them out easily without affecting the other modules.
That's a great example of how low coupling makes your code more flexible and adaptable. It's like having interchangeable parts in a well-designed machine.
Absolutely. Let's look at another example. Imagine you're building a web application that uses a third-party API to retrieve data. In a tightly coupled system, you might scatter calls to that API throughout your code base. What happens if the API changes?
It would be a nightmare. You'd have to hunt down all those API calls and update them one by one.
Exactly. But you can avoid that headache by introducing a dedicated module that acts as an intermediary between your application and the external API. This module would encapsulate all the logic for interacting with the API, providing a clean, well-defined interface to the rest of your application.
That's a great way to manage external dependencies. You're basically creating a buffer zone that protects your code from changes in the external API.
It's like having a dedicated translator who can speak both the language of your application and the language of the API. This approach not only reduces coupling, but also makes your code more testable. You can easily mock the API module during testing without having to worry about making actual API calls.
Okay, so we've seen how high cohesion and low coupling can be applied in an e-commerce application and a web app that uses an external API. Are there any other real-world scenarios where these principles really shine?
Absolutely. Think about any complex system, an operating system, a financial trading platform, a self-driving car. These systems are built from thousands, even millions of interacting components. Without high cohesion and low coupling, they would be impossible to develop, maintain, and evolve.
It's like the difference between building a house with prefabricated modules versus trying to construct everything from scratch on site.
That's a great analogy. High cohesion and low coupling enable us to create complex systems by breaking them down into smaller, more manageable units. They allow for specialization, reusability, and independent development.
All right, we've covered a lot of ground today. Any final thoughts or words of wisdom for our listeners as they embark on their own coding adventures?
I would just say this high cohesion and low coupling aren't just abstract principles. They are practical tools that can make your life as a developer easier and more enjoyable. So embrace them, experiment with them, and most importantly, have fun with them.
Well said. Remember, writing well-designed code isn't about achieving some kind of theoretical perfection. It's about creating software that's robust, maintainable, and a joy to work with.
Exactly. It's about crafting code that you can be proud of. Code that stands the test of time and makes a positive impact on the world.
I love that. And with that inspiring thought, we've reached the end of our deep dive into high cohesion and low coupling. I hope you found this episode insightful and helpful. Don't forget to check out the show notes for links to additional resources and examples. And until next time, keep learning, keep coding, and keep diving deep.